Hi everyone, in this video we're going to talk about the basic formulas we need to know for exponential functions. So let's start with the basics, exponential growth and decay. Any exponential function is in the general format y equals ab to the x, where a represents the y-intercept or the initial value, and b represents we call the growth factor, or decay factor if it's decaying. The growth factor, the b, or the decay factor is either 1 plus the rate if it's growing or 1 minus the rate if it's decaying, where r is the rate. So notice we have x in the exponent, and that's important as well, and b is the base. All right, so if it is growing, then we have 1 plus the rate, and 1 plus the rate is the base. Thus, the base, b, is greater than 1. And growth is going to look like this. Okay? If it is decaying, then the base is going to be 1 minus the rate, or it's going to have a negative rate, and then that means that the base is less than 1. It's actually a number between 0 and 1, and decay is going to look like this. Okay? So, a couple of things to note about the exponential function. There is what we call an asymptote. Specifically, it is a horizontal asymptote at the x-axis in this case, and the y-intercept, but no x-intercept. If there is no vertical shift, then the y-intercept is 0, 1 or 0, a, depending on what the situation is, where a is the initial value. All right, now let's take a look at some Regents questions. The first one says, which function represents exponential decay? So my advice is to graph all of these in the calculator, because if you look at the base, you may be fooled because these are not in the format y equals ab to the x. You need to have a 1 in front of the x for you to really truly evaluate if the base is growth or decay. If there's any number in front of the x besides 1, you actually truly don't know if it's growth or decay. So if I look at choice 1, I see the base is 1/4. I might think, oh, 1/4 is less than 1. That must mean decay. But then what I realize is there's a -1 in front of the x, which actually means that this is 1/4 to the -1 power, which is not 1/4. It actually is 4/1 to the x, which really means it's growth. So what I'm trying to say is graph all 4 and see which one is going to be going down. So you do that, please. So as you could see in Y1, I put in choice 1 and I have highlighted Y1. So if I hit graph or zoom 6, that is growth, not decay. However, if I turn off Y1 and I put in choice 2 by hitting enter on the equal sign to turn it back on, you're going to see that choice 2 is actually the winning answer, because this is the one that is decay. 1.8 to the -1 power is actually equal to 1 over 1.8 to the first, and that actually is going to be the decay. So the answer is choice 2. All right, let's get into some more, a little more word problems now. The value of the automobile after t years is represented by this function. Which statement is true? Okay, so notice t is in years. That's really important to note if the exponent is in years and months and days, because that actually does play a role. So this rate that we're going to get is actually going to be per year, which is nice. So notice that the base is b is 0.84, which is less than 1. This indicates that this is decay, not growth. If you know it's decay, you know you're going to pick one that says decreases here. So you know that you could cross out choice 1 and choice 3. Now we have to find the rate. So remember, the base is equal to 1 plus the rate or 1 minus the rate. I'm just going to put 1 plus the rate, and I'm going to show you that when I solve for the rate, I'm going to subtract 1 from the 0.84, and I'm going to get a negative number. It's going to be negative 0.16. This actually indicates that it is 16% decay per year. So the answer to the question is choice for 16% of decay. So even if you had graphed that in y equals, you would have seen that it was going down, and down means decay. So at least you could have been down to choice 2 and 4, and then you could have thought about that. The amount that actually remains is the 0.84. That's what is maintained, and then the amount that decays is what went away with respect to 1. So 1 is kind of like 100% the baseline, and then you either gain from 1 or you take away from 1. So in this case, 16% went away and 84% remain. Now let's go to number 3. Number 3 has 2 towns and they have different population rates. And it asks, if the trend were to continue, how many years will it take for these populations to be equal? So the first thing we need to do is write the equation for both Jonesville and Williamstown. So to do that, first you're going to make your rate a decimal. So to do that, take your percent and move it 2 decimal places to the left till you get your rates as a decimal. Now we're going to write our Jonesville and our Williamstown equation. Jonesville is going to be y equals ab to the x, where a is the initial amount, 1240, times 1 plus the rate, 1 plus 0.06 to the x. So if you rewrote that, that would be 1240, 1.06 to the x. Williamstown, I'm going to call it w of x, is going to be y equals initial amount 890 and 1 plus 0.11 to the x. Okay, so that is 890, 1.11 to the x. So right now what you're going to do is you're going to put in y1 and in y2 the two equations, and you're going to see where they intersect. So please do that now. But please note, you're going to have to change your window. So as you can see, I have in y1 and y2 the two equations, but when I hit graph or zoom 6, I cannot see them. So what I have to do is I have to change my window, and I want to make my y maximum bigger than 1240, 1240. So I'm going to make my y maximum like 2000. Why not? And then also I want to make my x maximum bigger than the biggest choice in the answers, which is 125. So I'm going to make my x maximum maybe 200. Now I'm going to hit graph and see what happens. So I made my window too big, but I can see the intersection. If I want to make my window a little smaller, maybe I'll make it 100 and hit graph, and I could see it a little better here. Now I'm going to hit second trace, and I'm going to do number 5 intersection. I'll scroll to the right until I see my cursor, and when I get close, I'm going to hit enter, enter, enter. I ended up getting an answer of 7-ish. So that means that when x equals 7, these two are going to be approximately equal. Now for this next question, they give you an equation and they tell you that it represents the amount of the substance that is remaining after t days. And it says, what is an equivalent form? So basically what you need to understand is that this is not in terms of 1t. This is in terms of actually 1 over 0.0803 times t. So if we want to evaluate what's happening per whatever it is, in this case is per day, we need a 1t in the exponent, not a t over 0.0803. So what you have to do is take your base, which is 0.5, and you have to raise it to everything except for the t. Like leave the t on the outside there and just take this exponent and raise your base 0.5 to that exponent, okay? So you're going to do 0.5 to the 1 over 0.0803 and see what you get for the new base, because that's going to be the real growth factor for B, okay? So do that now. Go to your home screen, type in 0.5 caret 1 over 0.0803 and see what you get. So notice I get an E, which means scientific notation, for 1.783 times 10 to the negative fourth power. 1.783 times 10 to the negative fourth power, which really means 3 zeros and then 1783. So this is looking like choice 1. Now, another option that you can do is y1, y2. So you would go to y1, you would type in the original equation, but you would have to pick a value for the initial, which is a sub 0, because we don't know the initial value. So maybe like let a sub 0 equal 100, whatever. Or if you want, you could drop the initial altogether. So I'm going to go to y1. I'm going to do 100 for a sub 0. I just made that up. 0.5 caret x over 0.0803. That's going to be my y1. And then my y2 is going to be all the choices. I'm going to pick choice 1 because I know that's the winning answer. So I'm going to type in a sub 0, same 100.000178 caret x. And it might not be totally equal because I rounded a little bit, but you do see that it does graph on top of itself. So anytime you see the word equivalent, you can do the y1, y2 strategy. The next thing that we need to review, and I need you guys to memorize these, are the compound interest formulas. And these are not on the reference sheet, so you really, really, really have to memorize them. Okay, so the first one is compound interest. If it asks you for it to be compounded annually, weekly, daily, quarterly, monthly, you have to use this first formula here, where the P represents the principal amount. So if we're talking about money, that means the initial amount. The A represents the final amount. The R represents the rate, the interest rate, as a decimal. And the T represents the total time elapsed in the bank, for example. And then the N represents the number of times the interest is compounded per year. So let's say we're talking about annually, that means once a year. If we're talking about quarterly, which is common, that's 4 times a year. And monthly is 12 times a year. If they said weekly, it would be 52 times a year. Daily, 365. Semi-annually would be twice a year. If they ever use the keyword continuously, then you need to know that's actually a different formula. And that one is when you use the base E. E is equal to 2.718-ish, and that is a decimal. And remember, we can get that E button by pressing second division sign. There it is, and you see it's about 2.718. Okay, it's an irrational number. And if you ever see that keyword continuously, then you're not going to use that 1 plus r over n to the nt formula. You're going to use PERT. A equals PERT. All right, so let's go to some examples. Okay, 5,000 is put in the bank. That's the initial. The rate, 3.5%, so we want to make that a decimal. Compounded monthly, that's 12 times a year. And how much money are we going to have left after 6 years? So that's going to be the time. Okay. So first thing is I would underline where it says compound monthly. I would make sure you write down that formula that we have to memorize for compound interest. And then we're just going to substitute. So I plugged in for the P, the R, the N, and the T. And now just plug it in the calculator and get your answer. So I got choice 4, 6166, 50-ish. Next one, here's the real Regents question. Number 1 was kind of easier, but here's the real Regents question. Susan won $2,000. She invested into an annual interest rate of 3.2%. If her investment is compounded monthly, which expression best represents the value? So if you notice, these choices are not of the same structure as the one that I just did, but we're going to still set it up. And then we're going to have to try to manipulate our response to make it match one of these choices. So the initial amount is the 2,000. The rate is 0.032. Monthly is still 12. And then the time we don't know, so we're just going to write T. We're going to set up our formula in terms of the compound interest. And then we're going to see if we can manipulate it to match. All right. So we know the 2,000 is in the front. But notice some of these have a different growth factor. So I want to remind you that the growth factor is everything except for the 1t. So if I had taken, let's start with this. Take your calculator and plug in 1 plus 0.032 over 12 and see what you get. That's going to be the growth factor without the 12. So I get 1.0027. That's going to be the base. To the 12t. Is this a choice? Is this a choice? Yes. You see the answer is choice 1. So notice that the 12 in front of the t indicates monthly, and that's important to note. 12t and t. You guys try this one, set it up and see what you get. So the main thing that I'm hoping you notice here is that the time it says is in years, but then they give you the time in months. They give you 24 months. So you don't plug in t equals 24. You have to make that into years. So that's actually going to be 2 years. So you're going to plug in a 2 for t. The other thing to note is that the rate r always has to be converted to a decimal. So you don't leave it as 1.25, you have to leave it as 0.0125. So that's why our answer is 3, because it's 0.0125 for the rate, and then the time is in years, so that's why there's a 2 and not a 24, which is the other choice. So this all culminates in this kind of question, which is very common lately. They're going to give you an equation and they're going to say that x is the time in years. So this is actually an annual equation. Annual means once a year. And thus the annual growth factor is this 1.0325, which means that if you were to take away 1 from that, you would get an annual growth rate of 0.0325 or 3.25% per year. So then what would it be in terms of per month? You have to know that the growth rate per month is going to be less than for the over the whole year. So we want to convert it to say something with a 12t or a 12x. So keeping that in mind, we already look like we're down to choice 3 and choice 1 basically. But which one is it going to be? Well, it can't be 1.0325. If 1.0325 is the annual or yearly growth factor, it can also be the monthly growth factor. So I'm thinking that the answer is choice 1, and I'm going to explain why right now. If your base is unknown, B, and you want a 12t, remember before it was 1.0325 to the 1t or 1x. So you take 1.0325 and you set it equal to b to the 12th. Then what you do is you raise both sides to the reciprocal of 12, which is 1/12. And you should get the 1.027 out. So take 1.0325, which is the annual growth factor, and raise it to the reciprocal of 12, which is 1/12, and indeed we get 1.027. If you know that it's going to be NT, where T is 12 for representing monthly, you know the answer has to be 1 or 3, and it can't be the same number as the annual rate, so that's why I crossed out choice 3. Now the calculator strategy is you just do y1, y2 because it says equivalent. And it says approximately equivalent, so it's not going to be perfect. But basically what you would do is go to y1, you would type in the initial, which is 35,000, 1.0325 to the x, and that's your annual equation, and then you would type in the choices and see which one is approximately equal to the other one and see if indeed it does graph on top of itself. So again, I don't see it if I'm in Zoom 6, so I will want to press window and make my Y maximum maybe like bigger than 35,000, make it like 50,000, and then hit graph, and you should see it that it, not perfect, but it does pretty much go on top of itself. The last thing we're going to talk about is doubling time and half-life. It is the same structure, y equals ab to the x, but the b, which is the base, is different. Remember, the base is either growth if it's greater than 1 or decay if it's less than 1. So keep that in mind here. The initial amount is still the same, a sub 0. That's the initial amount of a substance if we're talking about a radioactive substance. The final amount is on the left-hand side. That's like the y. That's the amount that remains at the end of the time period. The T is the total time elapsed, whatever it may be. And then the H and the D represent either half-life, if they give you a half-life, or doubling time, if they give you a doubling time. So that's the time it takes for the initial amount of the substance to either have or double, depending on the case. Notice if it's doubling, the base is 2. Notice if it's having, the base is 1/2, which kind of makes sense. You guys also have to memorize these, so that is something that we need to add to our list of things to memorize that are not on the reference sheet. So let's take a quick look at this question. It says that we start with 100 bacteria. That's the starting amount. And it says it's going to double every 30 hours. That's the doubling time. So right away I know A sub 0 is the initial amount. And I know the doubling time D is 30 hours. says write an equation for the number of bacteria B that's like the final amount in terms of the number of hours T of doubling time. So hours, hours, so that's important. So we're going to do initial amount, which is A sub 0, 100, doubling, so that's 2, and then it's T over D, so T over 30. That's it. We're done. So here is a more common Regents question. They'll ask you which of the following is true based on a given equation. So the initial amount of the original is 50 grams. This is true. So 2 is true. And then it says that the mass is decreasing by half each year. So if this says 1/2 here, that means that's the half-life formula. So remember, it's 1/2 T over H, where H is the half-life. So based on that, this is T over H. That means the H is 5715, which means that it's the half-life is 5715. So every 5,715 years, it's going to decrease by half. So this actually is false. The half-life is not every 1 year. So the answer is 2. The last thing I want to talk to you about is if you get one of these crazy long questions for about mortgage, this is a really real life example where they give you something where you're talking about a mortgage or a down payment and you have to figure out the monthly payment. So the advice we have here is just really read the question thoroughly and underline all the key information and try to really define anything that is given in the question on the side so that way you could clearly just plug into this crazy formula. And this formula is going to be given to you within the question. The things that you need to know are down payment. A down payment is the whatever the amount is you lay out to start. And basically that's important because that amount gets taken off of the total thing that you're borrowing. So let's say I'm borrowing $1,000 and I do a down payment of $100. I actually take 1,000 minus 100 to get what's left over. So it's the amount that I'm giving to kind of remove that amount off of that loan amount. So removed from the total loan amount. The amount borrowed is what I owe the bank. That would be the total loan minus the down payment. So I would take away my down payment from the total loan amount in order to figure out what I'm still borrowing from the bank. So let's say I'm buying a $500,000 house and I can't afford $500,000 out of pocket, but maybe I saved up $100,000 out of pocket. I would give the bank $100,000. So now I would take away 500,000 minus 100,000 and I would get 400,000, and then my amount that of the loan that I take out to the bank would be 400,000, not 500,000, because I already gave them 100,000. The N is the total number of monthly payments that you have to make. So let's say it's in years. You have to take the number of years that they give you. Let's say it's like a 30-year mortgage, and you have to multiply it by 12 to get the total number of monthly payments, like 30 times 12, for example. And lastly, the rate is always as a decimal. So very important to know how to take your percents and make them a decimal. All right, let's look at this question. Monthly mortgage payments can be found using this crazy formula below. Adam takes out a 15-year mortgage, so let's write that down. 15 years is the total time. Borrowing $240,000, so that's the amount borrowed. So that's actually going to be the principal amount here because that says P is the amount borrowed. So that's P. An annual interest rate of 4.5%, so that's going to be R, but we have to make it 0.045. What is going to be his monthly payment? Okay, so notice it says that N is the total number of monthly payments. So we have to take N, to get N, we have to take the total time, 15 years, and multiply it by 12 to figure out the total number of monthly payments. So go to your home screen and do 15 times 12, and that's 180 monthly payments. So you actually are going to be paying 180 monthly payments. Sounds like a lot, doesn't it? So now let's plug in and we're going to solve for M, which is the monthly payment. And they actually just asked you for the monthly payment on this. So they're asking for M. We don't know M. So this is the unknown, all right? So we're going to plug in what we know. The principal amount or initial amount was borrow was 240,000. So they didn't give me a down payment on this one. The rate is 0.045 over 12, 1 plus 0.045 over 12 because it's per month basically. The N is the total number of monthly payments, 180, which we solved up top. And then again, the denominator 1 plus 0.045 over 12 to the again N, so another 180 minus 1. Now you're just going to take this entire thing and put it directly in your calculator in your home screen, and hopefully we'll get one of our choices. So big fraction, $240,000, which is what we borrowed, times, plug that whole thing in, and let's see what we get. I'm going to pause it here. So as you can see, I plugged in this whole long thing and I got an answer of choice 3.